what is matter? It's a very different question than what's the matter. Matter is anything that occupies space and has mass. So I like this t-shirt. You occupy space, you have mass, you matter. Your textbook, your cell phone, your pen, all of these things are matter. They occupy space and they have mass. If we're looking at a specific type of matter, we call that a substance. So it's helpful to classify different types of matter. It helps us to understand them. And this is a lot like a child with some, cars and trucks, little model cars and trucks. And you could sort them by, you could put all the cars in one pile and all the trucks in another pile. Or you could say, well, I'm going to put all the blue vehicles over here and all the red vehicles over here. So that's what we're talking about here. We're classifying matter according to two different criteria. One is its physical state, its physical form. We can also classify it based on the composition. What is it made up of? So physical state, the three physical states are solid, liquid, and gas. I'm not sure why this is green. That reminds me of lime jello for some reason, but let's pretend that those are ice cubes. So ice is solid, and in a solid, the particles composing the solid are very close to each other. They're touchingly close. But they're not moving relative to each other. They're in a fixed position. If we heat that up, we can melt it into a liquid. And so ice melted would be called water. The particles are still very close to each other, but now they can move relative to each other. If we continue heating that, we can turn it into a gas, and now the particles have separated from each other, and they're free to move. So, in solid matter, atoms or molecules are close to each other in fixed locations. They do vibrate, though. They're moving, they're just not moving relative to each other. So my analogy for the states of matter is students. So we're in lecture right now, and you guys are sitting in rows, right, in chairs at the benches. Are you moving? Yeah, you're just not moving around the classroom, right? Everybody's still breathing. Nobody's sleeping yet, so that's good. Some people taking notes, right? Looking around, that's fine. You're moving. That's what particles do in a solid. They're vibrating, they're wiggling, they're squirming. Okay? But they're not moving relative to each other. So solids have a fixed volume, their volume doesn't change, and they have a rigid shape. This roll of tape is this circular shape right now. If we come back tomorrow, it's still going to be that shape. If I put it in the sink, the shape doesn't change, right? And the volume doesn't change. We can classify solids by how those particles are arranged. We can have crystalline solids or amorphous. Amorphous literally means without shape. So a crystalline solid, there's a pattern to how the particles are arranged. And in an amorphous solid, they're just all jumbled together. So as students, in the solid state, are you crystalline or amorphous right now? Crystalline, because you're in rows, there's order, right? Amorphous people in the solid state might be like kindergartners, right? The teacher says, okay, come on up here and sit down on the floor for story time. Are 5-year-olds going to sit in rows on the floor? No, they're just going to plop down all over the place. So that's amorphous, right? There's no organization. In liquid matter, the particles are still touchingly close, but now they can move around. So that means that although liquids have a fixed volume, their shape is not fixed. So you take a glass of water and you pour it into a bowl. Its shape changes to take on the shape of the container, but the volume of the water doesn't change, right? The analogy for students here is during lab period. So in lab period, we're all in this same room. We have the same volume as before, but now you're free to move around, and there's a lot of movement in class, right? In a gas, there's a lot of space. The particles are no longer touchingly close. They're very far apart from each other. And so this is like when class is over, right? When class is over, the students effuse, we'll learn about that later, effuse out the door, and you scatter, and we don't see each other until Thursday when we come back for class. You're far apart from each other, free to move relative to each other, but you can also move further and closer, right? And so a gas has a flexible volume. The volume can change, and the shape can change. A gas will take on the volume and shape of its container.
So not a fixed location?
Pardon?
Not a fixed location
I'm sorry.
Where the gas is not like a fixed location, it could be like any.
Right, it's not a fixed volume. Gases are not fixed volumes. So, yeah, this is kind of a gross analogy, but there's nobody sitting up there. But let's say there was someone sitting up there and they had some bad chili yesterday and they let one rip, right? It's gas, right? Is that stink going to stay over there? No. It's going to spread out and fill the whole room, right? And eventually people at the other corner are going to smell that smell, right? That's what gases do. They just keep expanding until they are contained by a container. Now here, this room is not airtight. It could, the gas will go out the door. It'll just keep spreading and spreading until finally it gets to a low enough concentration that we can't smell it anymore. Gases are compressible though, because there's all this space. So here in this illustration, this isn't some particles with air in between. This is particles with nothing. So this air that we're breathing right now and looking through, and it looks like nothing, right? But it's full of atoms and molecules, but they're all widely separated from each other. You can take air and you can compress it into a smaller volume. It's going to take some effort, but you can do that. You can't compress solids or liquids. It just doesn't work. So any questions about those states? Yeah. So so the question is, what do you mean by compressing a gas? So those little tanks they sell at the party store with helium in them? So what that has in it is compressed helium gas. And you can let that gas out and fill up a whole bunch of balloons, right? And the volume of those balloons is way larger than the volume of that canister that you bought, because that gas was compressed. All the particles are squished together. They're still not touching each other, but they're squished a lot closer together. And so that's what compressible means. Does that help? A little bit? Yeah. Anybody else?
It's kind of like the gas can take whatever shape of the container.
Yeah.
And then the solids can go fill up a bigger container.
Right. So a solid is going to have its own shape. And you can't squish it closer together because the particles are already touching each other. They can't get any closer. But in a gas, there's all this space. And so you can force the particles to be closer to each other. You can make its volume smaller. And because they're able to move, it will take on the shape of the container. You take an ice cube from a bowl and you put it on the counter, and its shape stays the same, right? But if you do that with half a cup of water, and you pour it on the counter, its shape changes, right? It's just going to spread all over the place. So we've got this, the difference between these three is their shape and their volume. Gases are variable volume, variable shape. Liquids have a fixed volume, but variable shape. And solids have fixed volume and fixed shape. And if you think about water and ice, it kind of makes sense there. So another way to classify matter is according to its composition. So if we look at matter as a whole, look at a particular kind of matter and say, well, does this have a variable composition or is it always the same? If the composition is not variable, we call that a pure substance. So what do we mean by that? Well, water always has the same composition. pure water. I mean, you can put stuff in water, but then it becomes Kool-Aid or something. It's not just water anymore. Whereas a variable composition might be water mixed with sugar, right? You could add a little more sugar. You could take away some of the sugar, and it's still that mixture of sugar and water. So that's a variable composition, that's a mixture. So in a pure substance, the composition does not change, and then we can ask ourselves, well, can you take that and break it into simpler things? And if the answer is no, you have an element. An example of an element would be helium gas. A Goodyear blimp full of helium gas, which makes it float. This is individual atoms of the element helium, and you can't break those down into simpler substances chemically. Whereas a compound can be broken down. Example here is water. Pure water has these molecules containing hydrogen and oxygen. Can you break those molecules down? Yes, you can. You can take a 9-volt battery and put it in a glass of water and wait for a little bit, and you'll see little bubbles form at the terminals. The electricity is decomposing the water into hydrogen and oxygen gases. Hydrogen and oxygen are elements. They cannot be broken down, but water as a compound can. For mixtures, we can look at, well, is it uniform throughout? Does it look like a single substance, or does it look like there's 2 different or 3 different things in here? So if it's the same throughout, we call it homogeneous. Homo is the prefix meaning same. If it's different, there's different parts, then it's heterogeneous. So an example of homogeneous here is tea with sugar in it. You look at that tea and it just looks like a single thing, right? You can't see the sugar in there, but it is in there, and it's uniformly distributed. A heterogeneous mixture would be something like wet sand. You can see the water, you can see the sand, you can tell that there's more than one kind of thing in there. So I'm going to go through these kind of fast because I mostly said all of this. So pure substances is one component, composition doesn't change. A mixture has 2 or more components, and the composition can vary. So the pure substances, separate those into elements or compounds depending on whether we can make them into simpler things. So elements are things that cannot be chemically broken down into simpler substances. These are the basic building blocks of matter. So element is going to have only one kind of atom. A compound is going to have 2 or more elements, 2 or more different kinds of atoms that are connected to each other in definite proportions. Most elements are actually quite reactive and will combine with other elements to form compounds. It's fairly rare to find elements in nature just by themselves. Mixtures, we have heterogeneous or homogeneous depending on how uniformly it mixes. Heterogeneous, different, has different composition. Example being salt and sand. An example using soup would be something like chicken noodle soup. And you can see there's little pieces of chicken, and there's the noodles, and then there's the broth, right? It's not uniform. You could pull the noodle out, right? Well, this part's different than that part. Homogeneous, it looks like one substance even though it's multiple substances. So the picture earlier was sweetened tea. Can you think of a soup that would be homogeneous? Broth, yeah. So like chicken broth or beef broth kind of looks like a sweetened tea, right? But it doesn't taste like that. Or something like cream of tomato soup, right? Any of those creamed soups where they've taken a chunky soup and blended it. So they've made the pieces so small that it all just looks like one thing, right? So that's a homogeneous mixture. Okay, so in these images, the blue circle represents an atom of one kind of element. The red square represents an atom of a different kind of element. So which of these 3 represents a pure substance? So the difference between mixture and pure substance again, in a pure substance, all the parts are the same. All the little pieces of it are the same. In a mixture, you have two different kinds of pieces, or more. So A is going to be the pure substance, right? Because here we have this one unit here, it's a red and blue. This one's also a red and blue. Each of these individual pieces is the same. It's a red and a blue. Is this an element or a compound? It's a compound because it's composed of two different elements, and it would be possible to separate those. So that's the pure substance, and what are these two? Mixtures. Which one is heterogeneous? C. All the blue ones are on top and the red ones are on the bottom. I think this was an attempt to represent homogeneous, kind of uniformly distributed.
For compounds, can it be more than two elements?
Yes. Yep. Compounds can be, the minimum is two elements, but I don't know what the limit is. It can be a lot. Yeah, good question. So mixtures can be separated because the different components have different characteristics. They have different physical or chemical properties. So we'll just talk about a few methods of separating mixtures. One is called decanting. We'll do this in lab one day. So imagine a cup of water with sand in it, right? And you can carefully pour the water off the top and leave the sand behind in the beaker. That's decanting. You're pouring the liquid off the top. This is an illustration of distillation, which is a method of separating two liquids from each other. So let's imagine we had water and ethanol in here, and we're going to heat those up. Those two different liquids have different boiling points. The ethanol is going to boil at a lower temperature. So as we heat this up, the ethanol is going to start to boil, and it's going to go into the gas state. It's more volatile, more easily vaporizable. And then instead of just letting it go, we're going to trap it, send it through this cooling column, which will make it go back into a liquid, and then it's going to run down and we can collect it over here. And as this process goes on, we'll be collecting more and more of the ethanol here, and this will eventually become pure water. We can separate those based on their boiling points. We can also do filtration. Anybody have coffee this morning? Really? Only one? Okay, two? Okay. But you know how coffee's made, right? You mix the coffee grounds in the hot water, and then you pour it through a filter, basically, to filter out all the solid grounds, right? That's essentially what this is. So making coffee is filtration. You're separating a liquid from a solid by pouring it through filter paper that allows the liquid to pass through and not the solid. Oops. Another example from the kitchen is you boil some spaghetti, and then you pour the whole thing, the water and the spaghetti, into a colander, right? A bowl with holes in it, and all the water comes out, and then you've just got the spaghetti. You've filtered your pasta.